Hello everyone, I am Dr. Smrati Tripathi from Applied Science and Humanities Department, Ajay Kumar Garg Engineering College, Ghaziabad. This video lecture is for Mathematics 4, which comes in second year AKTU syllabus, and the code is KAS 402 or 302, and today we are discussing Statistical Techniques 2. In that Statistical Techniques 2, today we will go for discrete probability distribution, and in this discrete probability distribution we will discuss binomial distribution. Now, what is binomial distribution? You must have seen whenever probability comes, we always talk about an event, a trial, and we generally take questions on the toss of a coin or rolling of a dice. But sometimes some events repeat in nature, or we can say the trials repeat in nature. So in that event, if one, or in that trial, if one event occurs or do not occurs, or if we are tossing a coin, we get a success for getting ahead or a failure, or in an interview for the acceptance or rejection, or for a particular event, yes or no. So now to find the probability of happening of an event in n trials can be calculated by binomial probability distribution. In that we always assume that let us suppose A is an event. So in that event, if we are supposing that there are p trials, and then in that p trials, probability of happening of the event is p, and probability of not happening an event is q. So we generally assume that p plus q is equal to 1, because if an event will happen or it will not happen. So if it happens, the total probability will be equal to 1, and if it does not happen, then there will be no event. So what do we do to find the probability of our successes in n trials? We find that probability using binomial probability distribution. So to find the probability, we use this formula, which is PR is equal to NCR P to the power R into Q to the power N minus R, where N is the number of trials, R is the number of successes in that trial, P is the probability of success, and Q is the probability of failure. How we got this formula, that PR is equal to NCR P to the power R into Q to the power N minus R? So for this, I'll take a small example and explain to you that how we get this formula. In this example, we are having a coin and we toss it 4 times. There is a coin and we toss it 4 times, and we are saying that let us suppose X is the number of heads, and we want to calculate the probability of occurring head in X times. So let X is equal to Xi be the number of heads in 4 tosses of a coin. So you can see that if there are 4 tosses, then either all 4 times we will get the head, or we will get head in 3 times out of 4 tosses, or we will get head 2 times out of 4 tosses, or we will get head one time in that out of 4 tosses, or we will have head not even a single time in that 4 tosses. Now, if I want to calculate the probability of getting head all 4 times, then we can write it as 4C4, like means out of 4 all the time we are getting head. So, we can find it using combination, and we always know that probability is always favorable outcome upon total outcome. So, in this, what is the favorable outcome? Favorable outcome is that we want 4 times head out of 4 tosses. So, according to the combination, it becomes 4C4, and what is the total outcome? We are tossing it 4 times, and we have 2 sides of a coin, which is one is head and another is tail. So, for head and tail both 2 to the power 4. So, this will be the total number of outcomes which we can have. So, for getting the probability of occurring head 4 times out of 4 tosses, we can get 4C4 upon 2 to the power 4, which is here written as 1 by 16 or 4C4 upon 16. This can also be written as 4C4 into 1 upon 2 to the power 4 into 1 upon 2 to the power 0. All right. And similarly, if we want that head comes 3 times out of 4 tosses, then the same will become 4C3 upon 16. 16 comes from 2 to the power 4. Again, we can write it as 4C3 1 by 2 to the power 3 into 1 by 2. Similarly, if we want that the number of, or you can say the occurring of heads should be 2 times out of 4 tosses, then this will be the favorable outcome will be 4C2, like from 4 tosses we are getting 2 heads and the total number of outcomes is 2 to the power 4. So, this will be 4C2 1 by 2 to the power 2 into 1 by 2 to the power 2. And similarly, for one head occurring, we can get 4C1 into 1 by 2 to the power, this will be 3 into 1 by 2 to the power 1. I can write it vice versa as well. And this is 4C0 1 by 2 to the power 0 into 1 by 2 to the power, this is 4C0 and this is to the power 4. Now, if we see very carefully, please check, in the first one we are getting 4C4 1 by 2 to the power 4 and 1 by 2 to the power 0. Now, what we are tossing here? We are tossing here we are tossing here a coin. So, in the coin, what are the outcomes can be? The outcomes can be either head or tail. So, for what we want a head. So, we have chosen that the probability of occurring a head is P. What I am saying? P is the probability of occurring a head is P. So, what will be the probability? As we know that the probability is always favorable outcome upon total outcome. So what is favorable outcome? Out of two sets, head and tail, the favorable is head only. So it means the favorable number of events can be only one, and how many events or how many outcomes can be 2. So the probability of getting a head will be 1 by 2, and we always know that the Q is 1 minus P, hence Q will be 1 by 2. So we can write here like this can be written as 4C4 P to the power 4 into Q to the power 0. If P is 1 by 2 also and Q is 1 by 2 also, what is N here? 4. So I can write it as out of N tosses, if I want R times head, it will be NCR like 4C4. What is upper 4 here? It is the number of tosses. What is this 4 here? It is the number of times head occurs. So this is 4C4 P to the power 4 and Q to the power. Now this also we can write as 4 minus 4. This we can also write 4 minus 4. So this will be 4C4 P to the power 4 into Q to the power 4 minus 4. So you can say in short we can get NCR P to the power R into Q to the power N minus R. And you can see that's what I have written here. So when we want, when R is equal to 4, we get P4. As you can see here, we have already got 4C4. So similarly, we will get here because the number of tosses was 4. And how many times you want head? 4 times. So this is 4C4 half to the power 4 into half to the power 4 minus 4. And that's what we got when we did it without using binomial distribution formula. So you can see that whether we use binomial distribution formula or do not use, if we want that the probability of occurring head R times out of N times, we always get the solution in the same format. Now, why we are doing this? The question arises, if we can solve it by simple way, what is the necessity for binomial distribution? The necessity for binomial distribution comes when the number of tosses are so big that we cannot solve it by this way. Because here there were only 4 tosses, 4, 3, 2 and 1 and 0 heads can occur. So it was very simple to solve that 4C4 upon 2 to the power 4. But if there are 200 tosses, then how will we calculate? Are we going to solve it like this? No. In that case, we are going to solve it like this, right? We know the number of tosses and we want how many times success? 4 times. Then it will be 4C4 half to the power 4. What is half? Half, I have told you that I have calculated here, half is 1 by 2 and again Q is 1 by 2. So half is P and another half is also P. So we can write P to the power 4 and again Q to the power 4 minus 4. Similarly, if we are writing P3, we will get 4C3 half to the power 3 into 1 by 2 to the power 1. And if we are going to get P2, it will be 4C2 half to the power 2 into half to the power 2. If we are writing P1, it is 4C1 1 by 2 to the power 3 into 1 by 2. And similarly, if we are getting P0, so it is 4C0 1 by 2 to the power 0 into 1 by 2 to the power 4 minus 0. Here it is. So now this is the, see, we can get these values also and we can get the same values from this binomial distribution formula also. So this is the reason that if we are having n tosses and we want to get success in r times, then the probability of getting success r times comes from this formula, which is NCR p to the power r q to the power n minus r, and this is known as binomial distribution formula. Now the question arises, if there is a binomial distribution, then there must be its mean and standard deviation. Let's try to understand its mean and standard deviation. So we know that any distribution which is a probability distribution as well have expectation, and expectation is always summation x px. Expectation is always summation x px. Similarly, here if we are having the distribution function PR, then expectation will be summation r PR, and expectation is nothing but the mean, or in other words we can say mean is summation r0 to n r PR. On solving this summation r PR, on putting the value of r from 0 to n on and summating, we get mean is equal to NP. This is one way to find the mean by using the formula of the expectation. And similarly, if we go for the variance, the formula becomes summation r square PR minus mu square. We know that the variance formula is always nu2 minus nu1 square. It is what? Variance is always nu2 minus, sorry, this 2 is not there. So this is nu2 minus nu1 square. What is nu1? Nu1 is always mu, and what is nu2? Nu2 is r square PR. And again on summating it from 0 to n, we can find the variance of the binomial distribution. This is the one way to find the mean and variance. I am not focusing on this one because the question many times comes that find the moment generating function of the binomial distribution and hence find its mean and variance. So if the question comes as find the mean and variance of binomial distribution, then also you can use moment generating function formula. And if it is written that first find the moment generating function of the binomial distribution and find its mean and variance, then also you can use the same formula. So if we find the mean and variance using moment generating function, this will be a better option for us. So let's find out mean and variance of binomial distribution using moment generating function. And now we know that moment generating function, so now let's find out moment generating function of the binomial distribution. What is the formula for moment generating function? Moment generating function of any function is denoted by mxt. Moment generating function of any function is denoted by mxt, and the formula is summation 0 to n e to the power tx into function itself. Okay. Now here I have written ncx into p to the power x q to the power n minus x, because here the function is binomial distribution, and this is the formula for binomial distribution for which we are calculating moment generating function. Now what I have done, I have taken together the terms which have power x. So here there are two terms, one is e to the power 2x and another one is e to the power px. We have taken them together and we got n summation ncx p into e to the power t to the power x into q to the power n minus x. Now we can see, because we have already studied binomial theorem, that this is also the formula for binomial distribution, which we can write here as q plus p into e to the power t whole to the power n. So we got the moment generating function of binomial distribution is q plus p e to the power t whole to the power n here. We also know that the differentiation of moment generating function r times gives us nu r. What is nu r here? Nu r is the moment about origin. Rth moment about origin can be easily calculated by differentiating moment generating function r times by substituting t is equal to 0. And we also know that what is nu r? Nu r is summation fi xi minus 0, and what we want, we are taking r is equal to 1. So this is, I am taking 1. So this will become summation fi xi minus 0 to the power n up 1 upon summation fi. Now what we will get? We will get finally summation fi xi upon summation fi, which is nothing but the mean. So what is mean? Mean is nu1, and that's what we want to calculate. So it means if we want to get the value of mean of the binomial distribution and we can get the value of nu1, then our work is done. So that's what we are doing. We are calculating nu1. How can we calculate nu1? By putting r is equal to 1 here, and in this complete formula by putting r is equal to 1. It means for calculating nu1, we have to differentiate moment generating function one time. So that's what I have taken d by dt mxt. So on differentiating one time, and after differentiating put t is equal to 0. So when I will differentiate this n times, what I will get? N into q plus p e to the power t whole to the power n minus 1, and this, the differentiation of q will become 0 and this will occur as it is. So we will get p into p e to the power t. Now let us substitute t is equal to 0. When I will substitute t is equal to 0, this e to the power t will become 1, and again this e to the power t will become 1. What we will get? We will get n into q plus p into 1 to the power n minus 1 into p into e to the power 0, which is again equal to 1. We know that q plus p is always equal to 1. So we will finally get here n into 1 to the power n minus 1 into p. So finally we get np. It means mean of the binomial distribution is np. All right. Mean of the binomial distribution is np. Now it's time to find standard deviation or variance of binomial distribution. What is variance or standard deviation? Standard deviation is equal to under root of variance, and variance is what? Variance is nu2 minus nu1 square. All right. For now you see nu1 we have already got. because nu1 is the mean. What is rest? The rest is remaining is nu2. How can we calculate nu2? Again by using this formula, nu2 we can get. It means here in R is equal to, we have to put T, 2 everywhere. We have to put R is equal to 2 in this formula. So we will get nu2. Now nu2 will be d2 upon dt 2 mxt when t is equal to 0. It means we have to differentiate once again this whole value with respect to t, and then we have to put t is equal to 0. Now see very carefully. How many terms of t are here? There are two terms. One is q plus p e to the power t and another is e to the power t. On differentiating it once again, we have to use product rule u into v. So we have to assume one term as u and another term is v. So here we have assumed e to the power t as u and this as v. So on differentiating, we will get u as it is, differentiation of v, which will be n minus 1, because n minus 1 is the power, it will come out q plus p e to the power t whole to the power n minus 2, and again on differentiating this we will get q will become 0. Why? Because we are differentiating with respect to t, so q will be treated as a constant and this will be p e to the power t remains as it is. Now plus, now v will remain as it is and differentiation of u, where u is e to the power t. So the differentiation of e to the power t remains as it is. Now I am rearranging it. So on rearranging, I am taking np common everywhere. And I have also taken e to the power t, q plus e to the power t whole to the power n minus 2 common, as well as e to the power t common. Now what remains inside? The remains inside is, now this e to the power term will not come here. So this is what remains here, n minus 1 p e to the power t plus q e to plus p e to the power t. What I did, I am repeating it again. I have taken out np, which is outside from everything, or outside from complete factor, and then again I am taking common. What I am taking common is this e to the power t and q plus p e to the power t whole to the power n minus 2. Please pay attention. Here it is n minus 2 and here it is n minus 1. N minus 1 can be written as n minus 2 plus 1. So we can obviously take q plus p e to the power t whole to the power n minus 2 common. So what remains inside? This n minus 1 remains inside and this p e to the power t remains inside, that is inside. From second term, what remains inside? N minus 2 is already taken common. So what remains? Q plus p e to the power t to the power 1 remains inside. Okay. Now we are putting, now again what we are getting, np into e to the power t q plus p e to the power t to the power n minus 2 into e to the power t. On solving, when we solve it, see this minus 1 and this p e to the power t will cancel out and we will get q plus np e to the power t, and finally we have to put t is equal to 0. Now again when we will put t is equal to 0, please pay attention, this will become e to the power 0 and anything to the power 0 is equal to 1, and this will become e to the power 0. Once again, anything to the power 0, any variable, any term to the power 0 always becomes equal to 1. So what we get from here? We will get from here q plus p to the power n minus 1, which gives us equal to 1. So if I write here once again the same term, I am erasing it and I am writing it. when I'll write it here, I'll get NP, this e to the power t will become e to the power 0. This will become q plus p e to the power 0 n minus 2, and we will get e to the power 0 q plus np e to the power 0. Okay. Now again on writing this, we will get np, this will become equal to 1, this will become q plus p to the power n minus 2, this will become 1, and this will become q plus np, and that's what we are getting here. See, np, this will become 1 because we know that q plus p is always equal to 1, and this will become q plus np. So what we are getting? We are getting np into q plus np. So we can write here npq plus n square p square. So this we got nu2, and we know that standard deviation is equal to under root mu2. Mu2 is also known as variance, and mu2 is known as nu2 minus nu1 square. This is the 4th unit for the given syllabus, and we have already read all that moment generating function, moments about mean, moments about origin in the 3rd unit. So that is why I am using all these terms, because we assume that you already studied that unit 3. So this is mu2 is always equal to nu2 minus nu1. Now I am putting the value of mu2 here. So what is mu2? Is nu2. So in place of nu2 I have put npq plus n square p square, and what is nu1 square is n square p square. These two terms will get cancelled out, and we will get under root npq, which is the standard deviation for the binomial distribution. So we can say that mean and standard deviation of the binomial distribution is np and npq. Now let's take few questions and try to understand that how can we find the probability or the expected values of the given outcome from the questions. Now in this example, so now there are 800 families, and each family has 4 children. We have to find the expected value of a family which is having 2 boys and 2 girls. Then second part is at least 1 boy, and the third part is no girl. Fourth part is at most 2 girls. Here in the question itself, they have given that assume equal probabilities for boys and girls. So since the probabilities of boys and girls are equal, so again probability of having in a family there can be only a boy or a girl. So outcome is 2. So the favorable outcome is 1 and the total outcome is 2. So the probability becomes 1 by 2. And if P is 1 by 2, obviously Q will be 1 by 2. How many children are there in the family? There are 4 children. So the N is equal to 4 because we can select children out of 4 only, whether it is a boy or it is a girl. And how many families we surveyed? It is 800. So the expected number of families having 2 boys. See, please keep it remember in these type of questions, if you are taking P for a boy, then for all 4 parts you should take P as a boy. You cannot say that for one part we are taking P as a boy and for another part we are taking P as a girl. That is not possible. Then the answer will become wrong. Expected number of families having 2 boys and 2 girls will be NP2. Capital N into, because the probability which comes is always for one family and we want it from 800 families. So probability of having 2 boys from one family will be 4C2, and we are using binomial distribution. So according to the binomial distribution, it will be NCR P to the power R Q to the power N minus R. So this is 4C2 half to the power 2 and half to the power 2 is the family which can have 2 boys. And we are talking about 800 families, so it will be multiplied by 800 and we are getting the expected number of families having 2 boys and 2 girls is equal to 300. The second part is saying at least one boy. At least one boy means there can be one boy, but if there is 2 boys, no problem. If there are 3 boys, no problem, and if there are 4 boys, no problem. So it means we can have 1 boy also, 2 boy also, 3 boy also, 4 boys also, but there in every family there must be 1 boy. So we will add all the probabilities and multiply it once again by 800. How will we calculate that P1? P1 by using the binomial distribution formula. P2 same, P3 same and P4 same. How? By using binomial distribution formula. And on solving we will get 750. So the expected number of families having at least one boy is 750. Now third part is the expected number of families having no girl. No girl means there should be all 4 boys. There should be no girl, all 4 boys. All 4 boys means we want P4. P4 means 4C4 1 by 2 to the power 4. It is for one family. We want it from 800 families. So it will be 800 into 4C4 half to the power 4 and that will be 50. Now the expected number of families having at most 2 girls means maximum in a family they can afford 2 girls. Minimum 2 boys must be there. If there are 3 boys, no problem. If there are 4 boys, no problem. But if there are less than 2 boys, there is a problem. That's what they want. So we can take 2 boys, we can take 3 boys, we can take 4 boys. So a family which have 2 boys will be considered, a family which have 3 boys will be considered, and a family which has 4 boys will be considered out of 800 families. And on calculating we will get 550. Let us take next question. They are saying that the probability of hitting a target is 10% and 10 shots are fired independently. What is the probability that the target will be hit at least once? Now here P is equal to how many times target is been hit? That is 10 out of 100 times because it is given in percentage. So 10 by 100 and it will come 1 by 10. If we know P, we can easily find Q, which is 1 minus P. This is 9 by 10. And how many shots are being fired? That is N is equal to 10. Now what is the probability that the target will be hit at least once? Means at least one time it should hit. If hit 2 times, no problem. And if it hits 3 times, 4 times and up to 10 times, no problem. But at least one time. It means we can take R greater than or equal to 1. R can be 1 or greater than. So we always know that P0 plus P1 plus up to so on P10 is always equal to 1. What we want? We want the probability from P1 to P10. Hence, probability from P1 to P10 will become 1 minus P0 and then we can solve by using the formula for R is equal to 0 and we will get the value of 0.651. So, this was all about binomial distribution. Thank you so very much.